In this video, we are looking at the problems in the 8.2 slides. We're starting off with this one. A study of sleepwalking or nocturnal wandering was conducted, including information that 29.2% of 19,136 American adults have sleepwalked. And we ask, what is the actual number of adults who have sleepwalked? Well, to do this, we just need to multiply 29.2% times 19,136, which is the same as 0.292 times 19,136. And we can go over to Desmos, which is my preferred calculator, and just enter that 0.292 times 19,136, and we get 5,587.712. Now, we can't say that this number is exact because it has a decimal, and we can't have 712 thousandths of a person. That would be messy. So we just round this to the nearest whole number and get 5,588, which should be close enough for us. Moving on, we'll go back here. Our second question asks us to use that same sleepwalking data from the previous example to with n equals 19,136 and p hat equals 29.2%. And we ask, would a reporter be justified in stating that fewer than 30% of adults have sleepwalked? We're going to use a 0.05 significance level to test the claim that for the adult population, the proportion of those who have sleepwalked is less than 0.30. So coming back here is our information. We've got n equals 19,136. P hat is 29.2%, which, as we saw before, is 0.292. P is 0.30, and then Q is 1 minus P, which is 0.70. Our significance level is 0.05, which corresponds to Z is equal to plus or minus 1.96. So we want to calculate the value of Z. Z is equal to P hat minus P over the square root of PQ divided by N. So we can plug in the numbers we've got. P hat is 0.292. Minus P is 0.30 over the square root of 0.30 times 0.70 divided by n, which is 19,136. And we'll take this and we'll plug it into Desmos, the choice of a new generation. Here we go. We've got 0.292. Put this in parentheses. 0.292 minus 0.30 divided by the square root of 0.30 times 0.70 over 19,136. And there we go. We get a negative 2.414. We'll just round that to negative 2.41. Notice that negative 2.41 is less than negative 1.96. Since the value is less than our critical value for Z, this means that this is significant. The reporter would be justified in saying that fewer than 30% of people have sleepwalked. Sorry, I'm a little obsessive about my spelling sometimes. Okay, moving on to the next question. Go back to my slides first so I can show you this one. In testing a method of gender selection, 10 randomly selected couples are treated with the method. They each have a baby and 9 of the babies are girls. We want to use a 0.05 significance level to test the claim that with this method, the probability of a baby being a girl is greater than 0.75. Okay, so coming back here again, we have n equals 10, p hat equals 0.90, p equals 0.75, which means that q equals 1 minus 0.75, which is 0.25. The significance level is 0.05. So again, our corresponding z value is plus or minus 1.96. This time we're going to take the positive 1.96. Less than, we take the negative. If it's greater than, we take the positive. Okay, so then p hat is going to be 0.90 minus 0.75 divided by the square root of 0.75 times 0.25 over 10. All right, so we plug this in Desmos again. We get 0.9 minus 0.75 divided by the square root of 0.75 times 0.25 divided by 10. And we get a value of 1.095, which is approximately 1.10. Since 1.10 is less than 1.96, it's not in the critical zone, and thus, what were we saying for our statement? We're testing the claim that the probability of a baby being a girl is greater than 0.75. We can say we would reject this hypothesis. The data we have does not support the claim. The sample size here is too small for this to be an accurate claim. It may be true that the number of babies born female is going to be 0.75, but we don't have enough data to state that for sure. All right, that's it for this video. If you have any questions, please get in touch.